Welcome, colleagues. Let's jump right into this briefing, Rescuing Writing to Learn in the Generative AI Era.
So, how do we rescue writing to learn assignments from the generative AI copy-paste era? It's pretty much the elephant in the classroom right now.
We all use these assignments, right? We want that deep student reflection. But here is the reality we're facing today. A student can literally just copy-paste a generative AI text reply right into a typed assignment without reading or thinking about it at all. And the second that happens, writing to learn completely loses its utility. It's gone.
Now, the knee-jerk reaction is often, okay, let's just go back to pen and paper. But let me be super precise here. Handwriting is not a magical window into internal thought. I repeat, it is not. It doesn't magically represent, capture, or guarantee a student's real internal thinking. We can't pretend that it does.
There is a caveat, though. Handwriting could be a window into internal thought, but only if the student does it honestly, strictly from their own thinking. That's the absolute ideal scenario.
But what about reality? In reality, a student might still just use AI to get an answer. So what is the pragmatic gain here? Well, handwriting forces them to write down what the AI said. And because they have to physically write it down, that suggestion actually goes through their brain, at least to some extent. This means they can internalize the AI-suggested path or strategy. And for sure, that is way better than a mindless copy-paste of an AI reply that never even goes through the brain in the first place.
So how do we handle this handwritten work at scale? In the paper we're looking at, students handwrite their learning plans, their learning evaluations, and their learning reflections. Then a structured, training-free Quen 2.5 VL pipeline steps in. It takes all those handwritten pages and transcribes them into usable digital text.
Let's quickly run through the pipeline specs. It uses identity-aware prompting to track who wrote what, metadata separation so things like course numbers don't get mixed up in the essay text, student-level page grouping, and, this is huge, a human review loop.
I really want to emphasize this point clearly. This pipeline is a transcription tool. It is not an automatic grader. You are still the one applying your pedagogical judgment. This just gives you the clean text so you can actually scale the review process without drowning in paper.
What's really great is that we have authentic classroom evidence for this. This system was tested directly in HBCU undergraduate engineering courses, which means we're looking at real, messy, unstructured classroom data, not just a controlled lab setup.
And the numbers really speak for themselves here. When looking at transcription accuracy, standard Tesseract OCR had a pretty dismal 34%. A naive vision language baseline got us up to about 86%, but this structured pipeline, it hit 95 to 97% accuracy. And that massive gain comes entirely from the document structure, not just from swapping in a different AI model.
You can see exactly how traditional Tesseract OCR fails to capture document structure and meaning. It completely loses the pedagogical intent. Without structure, it just falls apart. Structure really is everything here.
So, are you ready to implement this in your own engineering courses? Because this is a seriously pragmatic, evidence-based method to keep those reflective assignments alive and useful.
I'd love to invite all of you to join this community research effort. Let's collect data together, let's analyze it together, and publish together. What will your students' reflections reveal when you finally have the tools to read them at scale? Thanks for joining me for this explainer, and I can't wait to see what we can do with this.